Patty Simpson with Simpson Math. In this video, we will learn about the hypergeometric distribution. And the hypergeometric distribution is just a discrete probability distribution. In other words, our random variable will be countable. It's a discrete probability distribution where we have a population of items and we're going to select from that population a sample, and we're going to do that without replacement. So that's the first thing that we're looking for, is that it's done without replacement. In the past, we've looked at the binomial distribution. In that case, it was always with replacement, or our probability stayed the same in binomial. But in hypergeometric, it will be without replacement, or our probabilities will be dependent upon one another. Here we also have the number of trials in our experiment is fixed. It's a set number of trials. There will still be two possible outcomes from each of our trials. We'll call one a success and the other a failure. Sometimes we just are able to split it into two groups. We call one success and one failure. In this video, I'm just going to give you three examples of a hypergeometric distribution, and we'll look at how each one of those is met. Here's the first example. Given an urn with 8 balls, 5 green and 3 white, 4 prisoners must draw from the urn without replacement. The guards execute the prisoners who draw a green ball. What's the probability one prisoner is selected? In this case, we do have a population of balls that we're going to choose a sample from, and we're going to do that without replacement. The number of trials in this experiment is fixed. There are 4 prisoners, so those 4 prisoners are the number of trials. They're each going to draw out a ball. It is a discrete distribution. Our random variable is the number of green balls that we choose, and we can count the number of green balls that we choose: 0, 1, 2, 3, or 4. Then there are 2 possible outcomes for each trial. We either are going to draw a green ball or a white ball for each one of those trials, a success or a failure. Here's another example. 5 police officers and 20 firefighters attend a conference. All 25 names are put in a hat, and 5 names are randomly picked without replacement. What's the probability that 3 police officers and 2 firefighters are chosen? Again, we have a population of 25, and we're going to select a few out of there without replacement. This is a discrete variable because we're going to be counting the number of police officers that we choose out of the hat. We could choose 0, 1, 2, 3, 4, or 5. The police officers are countable. Those names are countable. So then the number of trials is fixed. We're going to pull out 5 names. So the number of trials is 5. And we have 2 possible outcomes. We're either going to pull out a police officer or a firefighter. Assign one of those success and the other failure as your 2 variables, or your 2 outcomes from each trial. So that is hypergeometric. Our last example, Miss Stash is very organized. She keeps 4 knives with Tiny Tim's 16 toys in the playroom bin. Tiny Tim blindly selects 3 items from the playroom bin without replacement. What's the probability Tiny Tim selects at least 1 knife? So here again, we have a population of items in the playroom bin, and we're going to select a sample from there. We have a fixed number of trials. We're going to select 3 items out, and it is without replacement. And then we have 2 groups, success and failure. We have our toys and our knives that we are going to pull out of the bin. So all 3 of these are examples of hypergeometric distributions. In the next video, we're going to look at the variables of the hypergeometric distribution. Math made simple at Simpson Math. Thanks for watching.